It looks done.
It looks done.
It looks done.
On one side.
On one,
You're just going to have to kind of...
yeah, like a Greek sculpture, mate. You'll be fine. See what I mean by getting distracted? We're 15 seconds in. We're talking about Baden's hair. Luckily, he's got hair. Well, there is that. I was going to start singing "Everything Is Awesome" because I was thinking Lego, but yeah. All right. So on that note, okay. Cheers. Okay, we're going to find the equation. So we're now actually starting to talk maths. Like all the other ones, we've been describing it in general terms as shapes or whatever. Excuse me. We're now finding the equation of the locus of a point xy so that it is always 3 units from the origin. So what I would like you to do is think back to general terms. Think back to a way to describe it before you actually start to try and worry about the equation. Don't freak out about that. Think about what that means. It's an equation of the locus of a point, okay, whatever, that moves so that it is always 3 units from the origin. I'm just going to change that. Oh, no, I won't change that bit. Sorry, I'll change this bit, just that bit. I'm going to give it another name. Goat. See what I've done? I made silly. Good me. Find the equation of the locus of a goat that moves so that it is always 3 units from the origin. That's a big hint. What shape do you reckon it's going to make? It's going to make a circle. Okay. What is a circle? A circle is a locus around a point. It's a fixed path around a point. It's a path around a point at a fixed distance. Okay. Several ways to say it. I'm not sure which one you prefer. It's a path around a point that is a fixed distance. We have a fixed distance. 3 units from the origin. So you could even graph this if you wanted. You could draw a circle with a radius of 3. Okay, that's what it said. So what we have to do is we have to work out what it is. Now, like I said, you may recognize that as a circle whose center is what? It's the origin, so it's 0, 0. Okay? And its radius is what? 3. Okay, so you might look at that and go, oh, it's a circle. Center of 0, radius of 3. I can just write down the equation for that circle. If you can't write down that circle, like the formula, then what we can actually do is we can use the distance formula. Okay? It is a little bit more complicated. If you can recognize that it's a circle, you could write down that x squared plus y squared equals 9. Yeah. Sorry? Very similar, yes, yeah. What you've got to do is you've got to start with it, well, I'll show you. Distance formula. Do you remember the distance formula off the top of your head? Yeah. Or that. Cool. Or you could have d squared, yes. Depending what you want. Do you want d squared? Because we're going to have... Yeah? Don't bother me. Yeah? Yeah, but it's a distance. So it's basically absolute value. We don't worry about the negative version. Okay, so d squared. So we're happy with that? All right, so what does our thing look like at the moment? We have a point. We have a point xy. And it is? Three units from the origin, yeah? So I could have put that xy anywhere, any quadrant, any space. Cool? And we know that it's 3 units. So this is our point P, and that's our origin O. Happy with that? So we know that the distance, PO, equals 3. That okay? Therefore, PO squared equals 9. Happy with that? So we've got x1 and x2, y1 and y2. So, or other way around. So we end up with 9 equals x minus 0 squared plus y minus 0 squared. 9 equals x squared plus y squared. Does that make sense? Using the distance formula? Sure? Okay. All I've done is I've got my, I should put my coordinates in there as well. So O is at 0, 0. So I've got my x2, y2, and I've got my x1, y1. Okay. x2, y2, x1, y1. So that's what I've used. That's my distance, 3, and that's distance squared. So I've just substituted into that formula. Cool? Cool.